All right, welcome back to our series, or the start of, I guess, another series. We're going to be doing quick CAD Camp, kind of running through everything. It is right before the season, so we're just going to go through every possible tool and everything there is that you might need to know. We'll see what there is. So we're going to start in a new file. We're going to create a new sketch, and we're just going to go through all these tools here. I think most of these tools here. All of these constraints, we'll kind of figure out some of these together because I've never used them. So first off, you've got your line. This is a very simple tool. It'll allow you to create a line using 2 points. You can define this using a angle. So if we use our D key, we can create a dimension, which is here as well. And we can tell this to be 1 inch long. And then to give it an angle, we actually need to create a reference line to attach to. This can be wherever, but if we create this and make this a construction line, it's not going to be included in our profiles, but we can constrain things to it. So we're going to make this 30 degrees, simple as that. Next up, we have our rectangle. We have a lot of different versions of the rectangle here. Most common will be the 2-point rectangle. That's why it's bound to my R key. So this will allow you to define a rectangle using 2 points. Essentially, the first point is one of the corners, and the second point is the opposite corner, giving you a length and a width. So we can make this 2 inches by 2 inches, and we will see that that is a open profile that we can actually select there. Has 4 corners and vertical constraints and horizontal constraints. It has a length, and that's all there is to that one. If we go to these rectangles, these are just different ways to define a rectangle. So we can use 2 points and a third point. So this will allow us to create rectangles on an angle easier. Again, if we use our D key and various other constraints, we can figure out angles and set this up to be correct. This constraint here is our perpendicular constraint, meaning these two lines are perpendicular to each other, and then these are parallel. This line and this line are parallel, and this line and this line are parallel. So that is another type of rectangle. You'll notice the blue lines are, because this is not fully defined, so we can move it around. Black lines we want to see most often, or all the time, means this is fully defined, dimensioned. We know exactly where everything is. So looking for those black lines. Last but not least, we got the center point rectangle. So this will be defined by a center point and a second point that's one of the corners. This will give you, again, a height and a width. So you'll see this has actually 2 construction lines, or sketch lines, I guess as it calls here, going exactly 45 degrees from that center point to the corners. So those are your rectangles there. If we undo all of this, get rid of this, we can work on some other stuff. Moving on to the circle, we have a lot of different circles. You'll usually find yourself using a center diameter circle. This will give you a center point and then a diameter. So if you make this diameter 3, it's a diameter, or it's a circle with diameter 3 inches. You can also do this arbitrarily. If we click C, we can kind of just click anywhere. This is a undefined circle, so we can make it however large we want. But that center point there is locked with a coincident constraint. So if we get rid of that, we can go to our next type of circle, which is a 2-point circle. So we can place 1 point and then place the second point. This will come in all sorts of applications, but if we do that again, I believe we can create, wrong one, a circle with diameter 3 inches in that exact, I guess that just gives us a diameter and a tangent point. So that one's not fully constrained. Next up, we can do a 3-point circle. That will give you a diameter. We'll give you just 3 points anywhere in the circle. I guess that makes sense. Again, any 3 points will give you a circle, so that's how that's being defined. And then we'll go on to the 2 tangent circle. We're going to need some lines for this one, so if we go 2 inches this way and 2 inches that way, we can get a 2 tangent circle. So for this one, we're going to have to select 2 lines and then specify the radius of a circle. So we're going to go here, and then we can specify the radius of, I guess, 1.5 inches if we're looking for a 3-inch circle. So this is just a radius, as you can see signified by this R here. If we're seeing a actual diameter, we will have a circle with a line through it, as notated by that. So this is a diameter, this is a radius. You can see that down here as well. So if we delete it, or actually we're going to need, yeah, we can delete this again. And then we can do a 3 tangent circle, in which we will not need to define a radius. We will just pick 3 different lines, and the circle will become tangent to all 3 of those. If we, have defined, if these 3 lines are all constrained and defined, the third, or the circle itself, will be defined, and so we don't need to create any dimensions for that. Moving on from the circle, we have a polygon, or arc. I normally don't use these arcs. I will use circles in various ways, or ellipses, but as you can see in the instructions, or the little help panel, to use this arc, we're going to have to select a start point, an end point, and a point on the arc. So if we want to place a point here, and then a point there, and we can place a point somewhere around here in this arc, that's exactly where this arc's going to be. And then if we define this third point, I believe, is the center of where that arc is surrounded. So that's one of your arcs. Your second arc is a center point arc. So let's see which order we have to select these in. So we're going to select the center point, then the start point, and then the end point. So we're going to start center point, start point, and end point, and that will give us the another arc. Our last arc will be the tangent arc. Not sure how this one works. Oh, it's just based on where those 2 points are. And we can change the radius by this constraint here, I believe. No, that's the center point from our other arc. Let's try that again. Let's try a line that goes here, and an arc from that point. I'm not exactly sure how this arc is defined. It creates a center point here, which we can drag and move around. And this last point, whoa, I have no clue what's happening there. So this is the center of our arc, and this point is tangent to this line, and this is I believe, a point on that arc. So as we change the radius, yeah, this is the center point of the defined arc, and then as we move this in or out, that radius is getting bigger or smaller, and then this point that we selected here is tangent to this line that we originally had. So those are your 3 arcs. And then if we go to polygon, these ones are pretty easy. We're gonna create a reference circle here, diameter 3 inches. and then we're going to create a circumscribed polygon. So that means whatever point you're picking is outside the circle. So if we let's go back to that. If we make this 1.5 inches, not 1.56, and actually I'm realizing you don't need a circle for this, it will auto create its own. 1.5 inches, and then select 6. We can do 7, we can do however many sides we want, not 23, we can do, 3. It'll give us a triangle, 4 square, 5 pentagon, lots of possibilities, 10, keeps going. As you saw, we can do 23 here, nearly becomes a circle, and you know how circles work. So we're going to do stick with 6, and click that. You have a hexagon with a polygon constraint, meaning that it has defined this shape as a polygon, which is one of the ones we have here. And then next we have a inscribed polygon, which means if we delete this, all of the sides are going to stay within the circle that it creates. So if we do another 3 inches, or 1.5 inches because it's a radius, we'll have the entire shape within that circle that it was kind of previewing, again with this polygon constraint. And then the last one is a edge polygon, which is the measurement of the edge. So if you make a 1 inch here, it means this side length is just 1 inch, and every side length here is 1 inch. So that's another way to define it. Next up on this, we have an ellipse, which is defined by a center point, a major axis, and a point on the ellipse. So if we grab this point here in the center, it can create one there, and then we can do a major radii and a minor radii if we go 90 degrees to where we were, or we can just select any point on this shape for our third point. But I would usually suggest that you pick another one that's 90 degrees to where this was, because you'll have both of your radii known, and you can constrain those 2 points. Next up is a slot. I've never used this feature, but we will figure out how to use it. So I think for the center to center, we're just going to create the 2 center points and then our radius from those. So if we're going for a 1 inch, we're going to go for a diameter here actually. So these lines, this circle is well defined. I'm not sure if we create a dimension of this line as 2 inches, the full thing should be constrained, giving us that there. But that is a way to create a slot. You could also do it with 2 circles on the line, but this is much easier. It creates all the constraints for you, and you can dimension it pretty easily. Another way to do a slot is creating a start and end on the slot center line, and then specifying the slot width or entering the diameter of the arcs, which I thought was similar. So this is very similar way of doing this. I'm not sure how that's defined there. Let's undo that and try that back on the line. Can make that 2. And then if we do 1 inch here, oh, so this is not center to center. This is the overall length. Not sure why that wasn't clicking, but if we define this line, that will give us the overall length from end to end, which has its cases. If you're trying to do something tangent to another, that's the best way to do that. Our next slot is a center point slot. if we specify the slot center, okay, misclick there, of course. This two. So the first constraint was our center of our slot. The second point was the first rate, or the diameter, I guess the radius of the radius. And if we make this 1 inch, that's going to be our diameter. So this is half the length of the full thing, minus the radius of the circle itself. Again, each of these will have their own applications, but these are just different ways to do it. We can do an arc slot as well. So if we have 3 different points that make an arc, and then define a width, or diameter. This one we can make half an inch. That'll be similar to how we use our arc tool, but we'll give it a offset around the whole thing where we can create that arc. We have another arc slot here, which is the center point slot. And again, we will have a type of arc and the offset as well. So those are your various different slots. A spline, we will hardly use. You create different points that it will be tangent to, and then you have these different control arms that you can define. I'm not sure how to fully constrain these exactly, or how that works. But I'm sure you can find documentation. These will be useful if you're trying to route wires or create kind of an organic shape, or even, multiple patterns that's repeating over and over again. For that kind of thing, I don't really see us using that on our robot very often. The control point spline will create given control points. And so this will give you not points on the spline, but control arm points. Again, I'm not sure how these points relate to the actual curve itself, but they exist and they can be used. Moving on, we have a conic curve. Never use this on the robot. Select the start point, end point, and then the top of the vertex. Use the guidelines to create tangency constraint. Specify the row value desired for the shape of the conic curve. So we have start point and an end point, and a value here which will define the curve itself. I'm going to assume that defining that at 50% will be the half the distance between these two, which it looks like it is if it's around 0.5. So that will have its applications. Not sure what they would be. Point is pretty obvious. That one just creates points. You can use these as a reference. You can drag them around, define them using a dimension. You always have the center point as one of your points, so that's not a point you can delete. But these are useful for creating reference points, which you might have to use a lot. Text, I'm not sure what this is, but text you can create. This will kind of just use this for labels. So if you want to put a label on something, there's different settings and stuff you can have for this. Pretty straightforward, but yeah. And then last on the list, we have mirror. So if we can create a circle over here. We'll kind of do this. We'll create a line that's 2 inches. That will be we make this a construction line, and then to mirror this, we're going to select the two objects we want to mirror, and then the mirror line will put those over the axis. So if we move one of these things, the exact opposite will happen on this other side. So that's very useful when we're doing plates, brackets, anything that has exactly the same setup on the opposite side. And then, if you have a motor mount on one side, you can not select those objects to be mirrored. But if you're driving a belt across, all of those things will be super easy if you're using the mirror. For circular pattern, we're going to have a reference circle here. Oh, that's a construction line. Unselect that here. And then this will allow you to create a pattern in a circle. So we're going to create this as our object and the center as our center point, and create however many we want. We can select the distribution. So if we want a partial distribution where we're doing only a certain section of the circle, we can do that. If you're doing motor mount holes, this tool is super useful. Or if you're doing kind of a pattern around a certain central object, this can be useful. Next up, we have the rectangular pattern, which we'll use a lot when we're doing brackets and beams, especially on beams. If you're doing, 5 holes that you want for mounting a swerve pod or something, instead of doing each one individually and dimensioning them individually, you can create a rectangular pattern. So if we select this circle, we can create 3 of them that are spaced or within the extent of 2.2 inches. We can also select this as spacing, so we can make it so there's 2.2 inches between each of these. And then we can do it a grid as well. If we bring this distance out to more than 0, and we can do however many we want in each direction. We can also make it symmetric, so we can do a total of 3 in 2 directions. If we do 4, it will default to having 2 on one side and 1 on the other, but as soon as you go to 5, it will split it up again. Simple stuff like that. And then that's kind of it for rectangular pattern. You can do this with any shape, doesn't have to be circles. Super useful tool there. And if you want to edit this, it's good to keep in mind that you can just double click on this constraint and it'll bring up this menu again, so you can edit all of your various values. Okay, moving on. If we delete that, we have the project tool. This won't really be useful now that we've moved to a different CNC, but if you want to project a already existing face into a sketch and export that, you can export that as a DXF file, but you would kind of need an object to do that. And then sketch dimension, we already mentioned, is one of the most useful tools. You just have to use it to define various lengths. So we're going to move over here to kind of our editing tools. We're going to put down a rectangle here, and we can actually define that instead of just leaving it like that. We're going to do a 2x2, and we're going to start off with our fillet, which is bound to my G key. And this will make the corner round with a specified radius. So the radius of the circle right now is 0.5 inches. If we do 0.25, it will become even smaller. And then we can do up to the actual side length of this. So if we did 2 inches, it would become that full, the radius of that would be that full side. But we're usually not going to do things like that. So 0.5, that'll allow us to make edges smooth. Machining them easier, stuff like that. This will give you the tangent constraint. It's kind of creating a circle inside here and then trimming it down is essentially what this kind of does. And then you can edit that radius by making this, changing this. Double clicking is how you access that. Next up, we have the chamfer. There's different types of chamfers, but essentially this will be another way to smooth an edge, but it'll be a straight line, just cutting off that corner. So an equal distance chamfer, if we select this corner, it will be the distance of this edge length. So if we do a 1 inch chamfer, it will be half the distance of this length as notified by here. This one is a function of dimension 30, so you can see the fx1. This is 1 inch here. Actually, if we click on this and see that is sketch dimension D30, you can double click here, and this actually just says D30 here, which is copying this exact value here. Another chamfer that we can use is a distance and angle chamfer. So if we create the distance here of 1 inch and then do a 45-degree angle, this will be essentially our equal chamfer, but we can change that angle so that it's unequal, and we have a lot of options here, from obviously our 90-degree angle that we wouldn't do as anything, and then all the way down. It's kind of glitching out there. I guess it won't let us select that, but this has a different version of a non-equal chamfer, which we will find in this next one here. So if we go to the last one, 2 distance chamfer, and select this point, this will give us 2 different distances. If we do 1 inch here and 1 inch here, that'll give us our 45, but we can choose different angles or different distances for that. Next up, we will have our blend curve. This will kind of create a smooth transition between 2 curves. So we don't have curves on here right now, but that's what that tool is useful for. The next one is the offset tool. You can see this being used pretty often if you're trying to create a 3D print, a screw hole, kind of reinforce something. If you're trying to encompass it entirely, you can select your curve, which will be a closed shape, and then the offset from that. So it'll be equidistant from all of those points on your curve. So you can go inside or outside. If you're trying to create a tube, you can define the outer dimension and then create a inner wall thickness. Or if you've selected the inner wall thickness, you can create an outer wall dimension by this, and that'll be the distance between these 2 lines. Next up, we have the trim tool. So if we have overlapping geometries like this circle here, we can trim off a part of this and leave the other part. Again, if we can do that on the outside and leave only the part that's not-intersecting. We can do that for this line too, because it intersects this curve at a point. We can kind of delete these and trim that off. Be careful when you're using this tool, because it will get rid of some of the constraints, and will make your geometries unconstrained. Next up, we have the extend tool. So if we have this circle here, let's see if it'll work in this sense. We can use the extend tool to extend this line all the way to where it'll intersect our curve. So if we have things of varying lengths or heights, we can use this tool to extend to a certain point until it's intersecting that. And then we can do that again to the other side. And if we move this around, it will stay at that same intersecting point here and intersecting point here with that tool. Next up is a break. So this will serve as a similar tool to the trim, but instead of deleting the excess that it's created, it will actually trim at a point. So you can see that these 2 lines intersect at this line. So what we can do is break. If we select it, it's one continuous line. But if we want it to be different lines, see how if we drag this point up here, it'll bring this with it. If we break this at this point, it'll allow us to separate these 2 lines at this point. I'm not sure why that's still dragging that point there. Oh, okay. Well, it'll allow us to break at that point, and then we can delete this and trim this off. So that can be useful in some situations. Didn't know that's how that worked, but okay. And then sketch scale. I guess this would just scale the whole thing by a certain factor. Yeah, so all of our lengths are now exactly whatever that scale factor was. I don't see you using that very often. And then the move/copy will just allow you to move a set of geometries. Because these are constrained, it's not going to let us do that. But I really don't see a reason for you to be using move/copy because your geometries should be constrained. Moving on to constraints, we have a lot of different options in this menu. The horizontal and vertical constraints, as you can see here, will allow you to constrain a line with the axes. So instead of having to create a line, make it parallel to that line, you can use the horizontal and vertical constraints. The coincident constraint allows you to select 2 points that will meet each other. So if you're trying to constrain a point on a line to a circle, you can select the end of that line and the circle, and it'll make sure that that point is always touching some edge of that circle. Tangent. Hopefully you've learned about how tangency works in geometry or any math class. But this will allow you to constrain a curve, a circle, and make sure it touches another object at exactly one point. Exactly how a tangent works. Equal will allow you to constrain multiple objects to the same dimension. So if we have a circle here with diameter 2, and then a circle here with unknown diameter, we can use our equal to make this exactly 2 inches. And then if we change this diameter to 2.5, the other one will change as well. So this is super useful when you're making screw holes or really any geometries. The parallel one will make 2 lines parallel. So if we have a line here and a line here, we can make these 2 parallel by using the parallel constraint, and no matter where these get moved, they will always stay parallel to each other. Moving on from that, we'll have a perpendicular constraint as well. So if we have a line here and a line going off this direction, those are not currently perpendicular, but if we select this and this, it will make those perpendicular with that little T-looking constraint. Next up is a fix/unfix. So this will kind of just lock a constraint or dimension that you already have. So although this isn't constrained to this exact position, I can't move it around if I try dragging it. Whereas for this one I can, and then we can unfix. We can unfix that by clicking it again, and now we can drag it around. Next constraint is the midpoint. So if we take this, we can select this line and this. Sorry, not that line. We can select the point where these 2 intersect and this line, and it will make sure it's exactly in the middle of these 2 points. So if I stretch this out, it will always stay in the middle of where that is. Next after that is concentric. If I delete this equal constraint here and make this circle, dimension the circle to have diameter 1, I can make these 2 circles concentric by selecting this one and this one, and they will share the same center point there. The next one is the collinear constraint. So if I have a line that's slightly off angle here, or even on angle but unconstrained, we can make it constrained using the collinear constraint, and that'll make it so these lines are exactly in the are the same line essentially. This can be used if you have two lines that are kind of spanning a gap like this. If we make these collinear, they will be in the exact same line like that. Symmetry, I believe this works if we have a object over an axis. So select two objects and select the symmetry one. We can move them both at the same time, and they will stay the same distance from that line. The curvature constraint, I'm still unsure on how the curves in this, how curves exactly work here in Fusion, but I'm sure this has to do with the spline tool and the conic curve tool and the blending tool somehow, but I've never used it, and I don't think you will. So we've created a sketch with lots of different things. You can use all of these tools to combine and create a lot of, or essentially all of our pieces. What we're going to start off with now is how to make things 3D. So we're going to make a quick 2x1 tube, not 21-inch tube. So if you make that dimension 2 and that dimension 1 and hit enter, we will have a rectangle with dimensions 2 and 1. And then usually our side walls, or our wall thickness, will be either 1/8 or 1/16. So what we're going to use now is the offset tool, and we're going to enter just 1/8. We can use fractions. We can kind of do operations here as well. We can do 1 times, we can do lots of things. We can do 1 times 8 if you're trying to do repeating something. You can do math within these dimensions, which is super useful. So if we click enter there, we can see that this creates a profile here that will be our profile of our tube. So you can imagine if we take a 2x1 and slice off a super thin piece of that tube, it will look exactly like this profile here. So if we finish the sketch, we can go back to our home and we can use our extrude tool. So this will allow us to take that profile and extrude it in a direction. This has a lot of different settings here. We can extrude the distance to an object, but for now, and most of the time, we're just going to use a specified distance. So we're going to make this 6 inches long and use the new body tool. Now we've created a tube that's 6 inches long, and it's a 2x1 with 1/8 inch wall thickness. Another tool that you can use is the revolve tool. So this will allow you to revolve around a certain axis. So we're going to take this profile and wrap it around this axis here, creating a hollow cylinder with a center body. So if we use a section analysis here, we can see that there is a tube, and it's kind of got this little dowel on the inside from that. So familiarizing yourself with how these tools work is essential to CADing. Again, if we use that same revolve tool, we can create a very different shape by selecting a different axis even. So knowing how those tools work and thinking about that geometry is very necessary. Another one we have is the sweep. So if we create a line coming off of this profile here, what we can do is create a line going up 1 inch, and then if we go off to the side 1 inch, and we can go up another inch. and then we can dimension this 1 inch here. Make sure all of these are constrained with that black line. We can finish that sketch. And then if we take this and sweep, we can select this profile. And then if we select this path, the region of the path is parallel with the slope profile. Oh, because this line is parallel to this plane, or parallel to this profile, it is not gonna let us do that. So if we create a dimension here, that's a slightly not 90-degree angle, so we can do 135 here. That'll give us a interesting shape, I believe. So let's try that again and sweep with that path. I think because this is colliding, it's going to give us a weird geometry and won't let us compute that. So let's try that again. There we go. Okay. So this will follow this edge with that path. So if we're trying to create connectors for things, that can be useful. But yeah, those are some of our 3D'ing tools. It'll take a sketch that you've made and make it 3D. Some of the modifying tools that we'll use are here. Very often we'll use the fillet tool. If you haven't included a fillet in your sketch, you can do it after. It has the same properties as within that sketch. So creating that radius, which you've selected here, and that line, you can select multiple lines to create that fillet on. And if we make this point, if we do 1/8 here, because that's our wall thickness, 1/16 here, for some reason, you can see you'll have different options for how this corner looks. So we have a rolling ball versus a setback, and those are just different ways to make that corner occur. So different parts will require different things. And then among the other ones, we have chamfer will be the same thing. Shell will create will make the body, or the inside of a body, completely hollow. The draft will create what's called a draft angle. So if you're trying to create two shapes, here, I'll make a sketch to do this. We can do this in a new design. If you're trying to get two shapes to release evenly from one another, you'll use what's called a draft angle. So say this is the outer part of something, and we'll have the inner part. When these two shapes are all the way nested, these lines are super close together, and if they're actually touching, you'll have a lot of friction. But with the draft angle, if you take these three, if you take the inner object and release it, you create more and more distance between these side walls, and it becomes easy to release. So trash cans, stacking cups will have what's called a draft angle to make it easier to get them apart, and also keep similar geometry among them. So that's what this draft angle tool will help you achieve with various bodies. We have a scale tool again, similar to our sketching environment, and then the combine tool will take two different bodies and make them one. So if you've had two different shapes that you've created with two different sketches, you can combine them into one body using this tool. And those are kind of the basics for making your first simple object.